human safety is really important in manufacturing. We don't run like we did 150 years ago, where a loss of a finger is a standard thing and you come back to work the next day. Robotics is used primarily to put distance between people and dangerous machines, or people in dangerous working environments, hazardous environments, chemical exposure, things like that, and unsuitable working conditions, places where you wouldn't want to work, where people don't want to go and do a job. Robots can do it, and it takes the people away from that danger. Robots, for instance, they're also very good at lifting heavy things, where people have certain manual handling limits. Robots don't have that. We buy a robot that has a 125 kilogram payload, and they can lift things around that a human wouldn't be able to very easily.
So I think a very interesting point to make, actually, when talking about the UK's implementation of robots and how we look at robots is we look at robots and automation or automated systems very differently to the rest of Europe. If we take Germany, for example, Germany take on a robot, and they bring that robot into their company, and that robot then is with them. And that robot can be used for many different jobs. It may do application A for 2 years, and application B for 3 years, back to application A for a year. Whereas what the UK tend to do is they seem to pair up or match up the robot for the application, and they see when they're buying a robot that they're buying a robot to do that application for life. And speaking to my colleagues in FANUC over in mainland Europe, is Europe don't do that. They invest in a robot. And they invest in the robot then to stay with for the life of the robot, the life of the company, to do different jobs within. And the UK are just very rigid, and it's one robot for one application. And what that does then is it means that when you're investing high amounts of money in a robot or an automated system, is you're very narrow-minded, and you're thinking, wow, that's a lot of money to do that job. And if as soon as you open that kind of avenue up of I'm buying a robot to do multiple jobs over multiple years, you straight away, it makes that investment process much easier for yourself.
So robots are incredibly consistent and reliable. Their repeatability is parts of a millimeter. They use that to do incredibly consistent jobs all the way through. You can also generate a system that has a massive untended running time. If we aim for between 4 and 8 hours normally on our handling systems. So that means your operator spends 10-15 minutes loading and unloading the system, and the system will run for 8 hours by itself, while that person goes and does hopefully something more interesting or higher skilled during the process, which also gains you an additional shift once your company's closed in the evening, because they'll load it for the 10-15 minutes before they go home, and it will run for 8 hours before they get there in the morning.
What we often find is that when talking about robotics and the implementation of robots in industry, a lot of people will talk about investment, and they'll talk about how much investment is needed. But what we're actually finding is that there's quite often there's not sometimes the robot for the application. So we have to develop these new technologies and bring these new technologies on for the implementation of robots. If we work backwards from the human brain and the dexterity that the human has, that is the optimum. That is very, very, very hard to replicate, and in most cases is the perfect use of the hand and the brain, the way the brain learns. So that's the optimum. And if we work back from there, now you can see that gap between the optimum human kind of brain and hand and then a robot, a 6-axis robot. There's a massive gap between that. So the closer we bring that together, you will see more robots kind of being implemented within industry.